Jai Hind, I am Madhup Agrawal. Today's our topic is disk scheduling, that is very important for the operating system concept. So, first we know what is the meaning of magnetic disk in the computer architecture. As we know, different data are stored in the permanent manner. So, magnetic disk is the approach, or we can say storage device, that is used to write, rewrite and access data. It uses a magnetized process. So, how to retrieve the data from the disk or how to write the data into the disk. So, first we know the architecture of the disk, how disk is architected. The entire disk is divided into platters. Each platter consists of concentric circle that is called tracks. So, platter, track, and again these tracks are further divided into sectors, which are smallest division in the disk sector, and cylinder is formed by the combining the tracks at a given radius of the disk spec. So, with the help of this picturization we can understand. So, the disk surrounding round nature disk is divided into tracks. So, concentric circle 1, 2, 3 and so on, these circles are known as tracks, just like here shown, and this track is again divided into different parts. These parts are known as sectors. So, track, then sector, and this sector is the minimum unit which can be accessed in a particular time, single time unit. So, now cylinder meaning there are many platters on the disk. So, same tracks of the different platters, same tracks and same sector of the different platters are known as cylinder. So, first there exists a mechanical arm that is called read-write head. Now, how to read or write in this platters? So, a mechanism used a read-write head, just like here a read-write head moving forward and backward. With the help of this particular read-write head we can write or retrieve data from the disk. So, there exists a mechanical arm called the read-write head, and it is used to read from and write to the disk. These heads has to read at a particular track and then wait for the rotation of the disk of the platter. So, how to read, how to reach the particular head to a particular platter or particular sector. So, this particular head move backward and forward, and then this is rotated. When desired particular sector is come below this particular head, then data will be read. So, the rotation cause the required sector of the track into come under the head, and each platter has two surfaces. One is top surface and another is bottom surface. Each platter has two surfaces, top and bottom, and both the surfaces are used to store the data, and each surface has its own read-write head, one for upside and one for bottom side. This is just like this one. This is different platters, and each surface of the platter has read-write head, and the common rotating arm is known as the spindle. Now, different disk scheduling, how to move the particular this particular head into a particular track. So, different disk scheduling is used. So, first we know disk scheduling is the technique used by the operating system to schedule the multiple requests for accessing the disk, and disk scheduling algorithm, the algorithm used for disk scheduling are called the disk scheduling algorithms. The purpose of disk scheduling algorithm is to reduce the total seek time. So, first seek time means the movement time for the head. So, first we will see later. Now, different disk scheduling algorithms are there. First is FCFS algo, another is SSTF algo, shortest seek time first, scan algo, C scan, circular scan algorithm, look algorithm and circular look algorithm. Different algorithms are there. And the disk performance parameters, there are many disk performance parameters. The time taken by the disk to complete an input output request is called disk service time or disk access time. So, there are many factors: seek time, rotation latency, data transfer rate, controller overhead and queuing delay. So, the seek time, the time taken by the read write head to reach the desired track is called the seek time. Means track is sector is moving backward, this is head is moving forward and backward and the disk is rotating. So, to reach a particular head to the particular track is known as the seek time. It is the component which contribute the largest percentage of the service time, disk service time, and the lower the disk time, the faster the input output operation. So, we must approach our particular algorithm takes minimum seek time. So, our approach will be in this side. Second time, that is rotational latency. So, here the head move backward and forward, and then rotation latency means the rotation, our disk is moving. So, movement time of the disk, that is rotational latency. The time taken by the desired sector to come under the read write head is known as the rotational latency, and it depends on the rotational speed of the spindle. How much speed up spindle moves, then that depends on the spindle speed. And the third parameter, disk transfer rate, the amount of data that passes under the read write head is given amount of time is called the data transfer rate. The data taken to transfer the data is called the transfer time. Now, the disk scheduling, different, as we have seen different disk scheduling. First, we will discuss the FCFS disk scheduling algorithm. So, as the name suggests, the algorithm, this entertain request the order they arrive. In the order they arrive will be served. It is a simplest disk scheduling algorithm. The advantage is simplicity. It is simple, easy to understand, but it does not cause starvation to any request. This is advantage, means any request comes, then this will be served in the sequence. And disadvantage is it reduces, the result is increased total seek time. Our approach was that seek time will be minimum, but in this approach seek time will be more. So, this is some inefficient manner, but this is simplest one. So, first we understand how this works. So, just by taking an example, just see a problem statement. Consider a disk queue with request of the input output to block the cylinder. Now, cylinder number 98 will be served, 183, 41, 122, 14. This is 124, 65 and 67. Our FCFS scheduling algorithm is used. The head is initially where? Initially at the sector number 53, cylinder number 53. The cylinders are numbered from 0 to 199. The total head movement we will count how much. So, first, where is our head? Head is at cylinder number 53. So, with the help of this particular diagram, head is at 53, initially at the 53. Then, with the help of FCFS algo, first we will serve the 98 number request. So, first head will move at the 98, that is this one. So, head will move here. Now, the second request for the cylinder, that is 183. So, move the 183. Now, move 183. This is 183. Now, serve the 41. Where is 41? This is the 41. So, head will move at the 41 number cylinder. Then 122. Then from here to 122. This is 122. Movement. Then 14. Now, 14, then 124, now 124, then 65, now move the 65, this is 65, and then move to the 67, lastly move to the 67. So, how much movement this will? So, we will calculate by adding these movement. So, by adding this, first movement 53 to 98. So, first movement difference is 98 minus 53, this is difference. Now, our head is at this position. Now, second is 183 minus this particular distance 98. So, 183 minus 98. Second movement, this difference, the difference will be positive because we are calculating the movement, not in the direction forward or backward, total movement. So, we will calculate the absolute value. So, 183 minus this 41, 183 minus this 41, again the difference is this one. So, difference will be 122 minus 41, now difference is this one. So, 122 minus 14, now add the difference of this, that is 124 minus 14, add difference this one, and add the difference this. So, our total movement is this one, that is 632. Total movement is this one, 632 number of cylinders we are moving to serve this particular request using the FCFS disk scheduling algorithm. This is the simplest one. Now, we will move to the second, that is SSTF disk scheduling algorithm, shortest seek time first. This is the shortest seek time first, this is shortcut. In this algorithm services that request next which requires least number of head movement from the current position regardless of the direction, it breaks the tie in the direction of the head movement if tie is there. So, again the example, same example with the help of, now we will solve with the help of this particular algorithm, that is SSTF. So, now consider a disk Q with the request input output block of the cylinder, this one. The head is initially at cylinder number 53 and moving towards larger cylinder, means head is currently moving to in this side, currently at the position here, but movement direction is larger this side, servicing passive. The cylinders are numbered from 0 to 199 and same thing. Now, we are going to calculate how much movement is there. So, our first request is 98, but we are using the shortest seek time first algorithm. So, we are considering all the requests from the current position. This is which is the minimum distance we can cover. So, first in this algorithm, the nearest one request is the nearest one in this direction. The nearest one request is 53. So, this is in this direction 65. So, move to the 65 track number. This cylinder number 65. We will serve 65. Now, our current position is 65. Now, the list difference from this particular 65 to 67, which is difference is 2. So, move this one. Our request is completed. Now, from this position 67, which one is having the less distance? Which one is having? Our one request is 98, one request is 41. So, the difference, if we calculate the difference, then the 67 minus 41, that is 626, and 98 minus this particular 67 is, this is 31. So, the minimum difference is this one. So, our head goes to the this particular point, that is this will serve now. Now, our head is currently at the 41 position. Now, the remaining request we have served this one, we have served this one, this one, this one. So our current position is at this position. Now at this position our request is 14, 98, remaining request this one. So the nearest one is this particular 14. So we will serve this particular request. We already served this. Now the nearest is 98 from this position, so serve this one. Then nearest is this one, then this one, then this one. So with the help of this particular SSTF algorithm, we calculate the total number of seek time. So total movement, head movement, total head movement, first movement is this one, difference is this one. So 65 minus 53, second difference is this one, third is this one, fourth is this one, then this one, again, so on. So total head movement is 236 after calculating 236. So the same request, but serving algorithm is different. Now 236 total head movement, and in the previous we can see in the previous that total movement was 632, a significant difference we have got. Now 231 improvement, 236 and here 632, a large difference, large efficiency, large improvement by using the shortest seek time first algorithm we have achieved. So but just we can see, consider a disk system with the 100 cylinder, the request the access cylinder occur in the following sequence. This is sequence. Assuming that the head is currently at the position 50, what is the time taken to satisfy all this? By if we taking the 1 millisecond to move, a problem statement is there. Now calculate, this is assignment, means now here time is given 1 millisecond to move from one cylinder to adjacent one, means one cylinder movement time is 1 millisecond. Then calculate the total time in total seek time, shortest seek time. So this is a request you can solve with the help of this particular movement using SSTF. So this is given SSTF currently at the position 50, currently at the position 50. So which request will serve? Which request will be served? The nearest one request from the 50, that is, this is 34 and 50 difference is 16, and this request difference is, this is 23. So 34 will be served, 34 will be served, and then 20 will be served, then 19, 15, 10 this request, and then at the last 73 will be served. So with the help of this one, now total serving, total movement, how much total movement is there? How much total movement? We can calculate one by one. We can calculate the difference, this one, then this one, then this one, or we can calculate directly from here to here. Last request is 2 and we are moving from this. So total movement is 50 minus 2, and this difference is, last serving is 73 and this is 2. So 48 plus 71, that is, this is 119. Total head movement, number of cylinders is 119, and one track movement 119. One track movement is 1 millisecond. So 1 millisecond. So total calculation is 119 millisecond. So our option is 119 millisecond. Okay. Now we can see another algorithm. Head start from one end to the disk and move towards the other end, serving all the requests in between. If our head is moving towards forward direction, then all the requests in that particular direction will be served. If this is moving backward direction, then all the requests at that particular path will be served. And after reaching the other end, head reverse the direction. After reaching the other end, other last end, if total scale is this one, then our head is start from this one, serving all the request, and let the last request in this direction is this one, but our head moves at the last point also here, then revert back. End service all the request in between. The same process repeat. Scan algorithm is also called elevator algorithm. And advantage: simple, easy to understand, does not load the starvation, and it causes long waiting time for the cylinder just visited by the head. If our request comes just behind, if our head is moving in the direction and next request is served this, our new request comes at this point, then this will not be served because head is moving at this particular direction. This is simple disadvantage of this one. So just the problem is this one, same, by using the head is initially at the cylinder 53, yes, this is at 53 and moving towards the larger cylinder number serving path. So in this movement, so in the direction all the this particular request will be served. All the last serving our track was request was 183. So last is 183. This will be served at the last, but our head goes to the last point of this particular cylinder. So this movement is in this algorithm, in this approach, this movement is also necessary. Extra movement, or we can say this is overhead movement something, and then this change its direction and serve this particular request 41 and then 14, that is in the direction last request, and stop the process. So in the direction total movement is, we can calculate, this is 199 minus 53 and this is the 199 minus 14 total. So total total movement, head movement is 331 tracks in this scenario. So we will remove in the further algo this one. Now scan algorithm, this particular, if this moves in this direction, then goes up to the 0 number per track and then serve in the opposite direction. Same question, in this question head is moving at this particular direction, but for the same question, if head was moving in this particular direction, then what will be the answer? The answer is this one. If from here head is moving at this direction, then our serving will be this and this one. Now next is look disk scheduling. In the look disk scheduling is same as scan scheduling, but look algorithm is improved version of the scan. Head start from the first request at the one end of the disk and move toward the last request at the other end, serving all the requests in between. After reaching the last request at the other end, head reverse its direction. This is the difference. From the last request, head moves to the other direction. If a head is moving forward, then this will be move backward. If backward, then move forward at the after serving the last request at that particular direction. But in the scan, head was moving toward the last particular track also. That was the overhead generally. So this is removed in the look. It then returns first request at the starting and serving all the requests in between. The same process repeat. Advantage: it does not cause the head to move till the end of the disk when there is no request to be served, and it provides better performance in compared to the scan algorithm. It does not lead to the starvation. So unnecessary movement is removed in this particular algorithm, that is look. This is improved version of the scan. Now the same problem statement using this one. The head is initially at the cylinder number this one, moving towards larger side on the pass. So with the help of figure we can say, now we have stopped, reverse our direction at this last request, we can change our direction. So this difference as per in the scan, there is no necessary to come here at this particular last. So movement will be reduced, extra movement, this one is reduced again. Now another algo, C scan. This is another is circular scan. Circular scan is improved version of the scan. Head start from one end of the disk and move towards the other end, serving all the requests in between. After reaching the other end, it reverses each direction. It then returns to the starting end without serving any request in between, without serving the. Now we can understand this with the help of this particular figure. So our head is moving this direction, scan algo come to the last point and then to the first point at the zeroth location. Then this will serve in the same direction. This will serve. So this is the circular scan. This is known as the circular scan. Without in this, when head comes in the direction, then it will not serve any request, and when reaches to the beginning, then this will be serve the request. So total movement we can calculate, and same is for the C look. C look also the same nature as the C scan. In the C scan also there will be no serving request in this particular direction, and then we can calculate the total movement.